Question number 23 in coordination compounds put back. Give the oxidation state, d orbital occupation, and coordination number of central metal ion in the following complexes. The first one, we are asking oxidation state of central metal. Then d orbital occupation. And coordination number of central metal. Okay. So first complex K3CO C2O4 thrice. Okay. Now we have to consider the coordinated part alone because the question is about the central metal ion. Here, this is also metal, this is also metal. But this D block element alone is coordinated. Take the coordinated part alone, cobalt bonded to oxalate. Oxalate, we know it is a didentate ligand. So we can write like this. Okay, it forms a chelate complex. So from a single ligand, from two positions, bonding happens. Because oxalate is like this. This negative charge and this negative charge, they get bonded to the central atom. They fill the empty d orbitals in the central metal. Okay, and one more C2O4. So this is the structure of the coordination complex. Okay. Now what is the charge on the coordination complex? It is the opposite, the net charge on the coordinated complex. It is the opposite of the charge carried by the counter ion. What is the charge on single K? It is plus. For 3K, it is 3 plus. So the opposite will be on the coordinated ion. What is this? For the net ion, net charge on this ion is 3 minus. So that is the cumulative charge of the entire ions present in the, when you add up all the charges present inside the coordination sphere, you get the net charge. So when you are asked about the oxidation state of the central metal. The central metal you don't know, you put it as X. Oxalate, you know it is 2 minus, it is di-negative ion. So the charge on single oxalate is 2 minus, means for 3 oxalate, how much? 3 into 2 minus is equal to, what is the net charge carried by the ion? 3 minus. So X minus 6 is equal to minus 3, means X is equal to plus 3. The oxidation state of cobalt here is plus 3. So our first part of the question is over. Oxidation state of cobalt in this complex. In this complex is 3 plus. Plus 3 oxidation state. And what is the d orbital occupation? See, the oxalate ion is a strong ligand. So when we say first, whenever we form the whenever you need to know the d orbital occupation, you go for valence bond theory. Here cobalt 3 plus means first take the configuration of cobalt 3 plus. What is the electronic configuration of cobalt atom? It is 4s2 3d7. 3 plus means 2 it will lose here, 1 extra it will lose here, d6 it will be. So cobalt 3 plus, how will you write? 1, 2, 3, 4, 5, 6, 1. And when we take the complex cobalt trioxalate, here, since this is a strong ligand, it will involve D2sp3 hybridization. So you push this electron over here, this electron over here. So the hybridization of this complex will be These two orbitals have to be made vacant in order to utilize them for hybridization. So six coordinate bonds are there, no? So it will undergo, it is an octahedral complex. The octahedral complex, if the ligand is strong, it will force pair the electrons here and make these two vacant and make them available for coordination. So it will be it will undergo D2sp3 hybridization. And when these electrons are force paired here, what will be the configuration? D orbital occupation 2, 2, 2 here, and the D2sp3 hybrid orbitals. They will have pairs of electrons. So this is the d orbital occupation of the complex. These 3 pairs are the metal electrons and these 6 pairs are the ligand electrons. And what is the coordination number? Each metal is coordinated by 1, 2, 3, 4. How many bonds it is bonded to? That is the coordination number. So in all octahedral complexes, the coordination number of the central metal is 6. Understand? So what are the answers for the different questions? Oxidation state of central metal is +3. D orbital occupation is all electrons are paired, in which, since it undergoes D2sp3 hybridization, in which the electron pairs are ligand hybrid orbitals, electrons of the ligands are filled. The metal ion electrons are filled in the d orbital, like this. They are force paired, so all electrons are paired in the d orbitals. Then coordination number of central metal is 6. Understood?